Alright everyone, welcome back. We are now on week 1. Let's get into part A material. So part A is going to cover these 4 topics. First we're going to talk about numerical types. As promised, there will be a lot more types this quarter than just strings. Today we will talk about numerical types. We will also talk about converting between types and what that looks like. We'll talk a little bit more about strings and that print ability that we saw last week. And then we'll wrap up week 1 part A with a little bit of data representation. Alright, let's get started with numerical types. As a review, first let's cover what types are again. So again, types are a way to categorize all the data that you have in your code. The type specifically determines how the data is represented in the computer, which we will talk about this week, and also what operations can be performed on that piece of data. Alright, so now we're going to talk about numerical types. As a reminder, we've already covered string types, so now we're going to talk about 2 more types. Python specifically has 3 numerical data types: integers, floating point numbers, and complex numbers. That said, we're not going to cover complex numbers. They're still important, but we just don't have time to cover everything in this class. So for this class, as far as numerical types go, our focus is going to be on integers and floating point values. So integers are numbers which are whole numbers, meaning they have no decimal part added to them. Floating point numbers have a decimal point, so they have numbers after that decimal point. Here's a couple of examples. So integers, again, no decimal point. So for example, 0, 1, negative numbers are fine too, negative 123 for example. And then again, as far as Python is concerned, floating point numbers are any numbers with values after that data point, after that decimal point there. So 0.3333, negative 1.4. I think the most interesting thing is that a number like 5.0 is still considered a floating point number. So even though the decimal point value is 0.0, it is still a floating point number. So as long as there's any decimal point with a number after it, then it's a floating point number. So that's all Python cares about, is whether or not there are numbers after that decimal point, even if they're 0. So again, 5.0, not an integer, it is a floating point number in Python. Couple other things to keep in mind while you are working with numbers in Python. So numbers in Python can't have commas in them. So when you type out a number, just make sure there's no commas in it whatsoever. Also, if you're dealing with mixed numbers, like numbers with fractions, use decimal notation instead. So you can't type something like 3 space 1 divided by 2. That won't work. But you can use 3.5. Alright, so with most of the numbers, you'll of course be doing some math calculations. So a math expression is just a piece of code that performs such a math calculation, and it gives you a value. So for example, 12 plus 2, that's a math expression, because it does some math calculation and then it gives you a value back, like 14. Cool thing about math calculations, you can use variables in these math expressions. So remember, we talked about variables last week. If those variables have integer values or floating point values, then you can use them to do math expressions. Alright, so here's an example of how you might use some math in your code. So normally if you are doing some sort of math expression in your code, you want to save the value that's calculated by it. The way you do that is with an assignment statement, right? We talked about these last week. So here's an example. We have 2 variables here, these first two lines, these are assignment statements. They are making two new variables, salary and bonus. Into salary, we place this floating point value, 2,500.0. Into bonus, we place another floating point value, 1,200.0. And again, you can use these variables, which contain numerical types, as part of a math expression, such as salary plus bonus. Generally, if you do that, you're then going to want to store that result, so the result of that calculation, into a variable, right? Because that way you can use it later. To do that, you use our assignment statement that we've seen before. So again, with assignment statements, if there's any calculation to be done, that's done on the right-hand side. That is done first. Then it's placed in to the variable pay in this example. So this code, when it runs, it'll display a message at the end that says your pay is 3,700.0. Because essentially pay is going to get this value 3,700.0, the result of this math expression, salary plus bonus. I recommend opening up idle and typing this out in a new file just to make sure it runs as expected. Also, it'll help you practice a little bit with doing some math expressions and calculations in your code. So I recommend going ahead and pausing this video, doing that now, then come back when you're done. Alright, let's do a little bit of practice. So in addition to writing code with math expressions, you should also be comfortable reading code that's already given to you with math expressions in it. So with this type of problem, this is something that you should be able to do on paper, right? And the best way to handle something like this is to draw those little variable boxes that we talked about earlier. And of course, for something like this, maybe you don't need to, but when you get more complicated code, it's really good to get into the habit of drawing variable boxes. And what I mean by that is running through this code here, we have two variables, right? These first two lines of code, those are assignment statements, creating two new variables, putting values into those variables. So we have our first variable, which is x, and then another one, which is y, right? Those are our variable boxes. Those assignment statements put these initial values into them, 2 and 4. Then we have this line of code, x equals x plus 1. So again, with assignment statements, you want to do everything on the right-hand side first. So in this case, it's a math expression. Right now, x has 2 in it. So we're doing this math expression, which gives us 3 back. So we do the right-hand side first, and then we put this value 3 into the variable on the left-hand side. So now, this 2 up here is gone, and instead we have 3. All right, that's from this line of code right here. We keep going though, right, because there's more code here, going top down. Next line of code is this one right here. Y equals y plus x. Same sort of idea here. With an assignment statement, do everything on the right-hand side first, then put it into the left-hand side. So in this case, right now, at this point in time in code, y has 4, and x has 3, right? X has been updated a little bit since we first started running. So x right now is 3. Do this math, we get 7. So we put this value 7 into this variable y. So then, when you print y, you'll get this value 7 displayed on the screen. So again, doing those variable boxes, while for this example might be a little bit overkill, it's still good practice to get into, because as you can imagine, the examples will get more complicated as we progress with more days in this course. So I recommend at this point in time pausing this video and doing what we just did with the previous example, but with these 3 pieces of code. When you're ready to come back and see if your answers are right, go ahead and unpause the video. Alright, so hopefully these are the values you got. If you have any questions about any of these 3 examples, let me know. You are also welcome to try coding them on your own and running them just to verify these answers. So something that's really cool about this class is you can kind of make up your own what will this code do when I run it questions, right? Type up some code, figure out before you run it what it's going to do on paper, and then run it and see what happens. And that's kind of a twofold exercise, because not only do you practice problems like that, but you also practice writing your own code. So that's kind of cool. Alright, let's talk a little bit more about some math calculations you can do. So these operators can be used on numerical types. These are what we call the arithmetic operators. So we've already seen addition, just use the normal addition sign. Same thing for subtraction, use the normal subtraction sign, minus sign. Multiplication's a little bit different than what you might expect though. So for multiplication, you need to use this asterisk symbol. So this is what you get when you press Shift 8 on your keyboards. That asterisk symbol, the one that looks like kind of a flower, I guess. So that is for multiplication. Please be careful about that. You can't use X for multiplication. So make sure you're using this symbol instead. For exponents, so for powers, you use double asterisks. So Shift 8 twice. Alright, so again, those are for powers, exponents. Division's a little bit interesting. We will talk more about division in a second, but there are essentially 2 types of division in Python. There's what I call the single division operator, which is pretty much standard division, and then there's this double division operator, which we call floor division. We'll talk about those 2 in a little bit. And then the last operator I want to talk about today is this percent sign. So this percent sign means modulus, also known as the mod operator, and it essentially gives you the remainder, which is pretty cool. We'll talk about it though. So again, these are sort of an overview of the different math operators you can use for Python math expressions. Alright, let's talk about mod. So again, mod essentially means remainder. Alright, so the way mod works is you do division. So for example, let's say you have 7 mod 4 is how I would read this. 7% 4, you read that as 7 mod 4 or 7 modulus 4. To figure that out, you do the division and then you respond with the remainder. Alright, so 7 mod 4 is going to be 3 because the remainder of that division is 3. Same thing with 15 mod 2. That's going to be 1. So let me show you what I mean by that. So this is going back to our days of long division. So when you're doing long division, right, you do something like, let's see, we'll do the 7 mod 4 example first. So back to our days of long division, we're trying to figure out how many times 4 goes into 7. So again, right now we're calculating this 7 mod 4. So we do this long division here. Alright, well 4 goes into 7 one time, right? 1 times 4 is 4, and then you do this subtraction and you get 3 left over. Right? This is back to, you know, 2nd, 3rd grade, 4th grade, whenever you learn long division. Before you learned about fractions, you just went ahead and once you got this 3 left over, since 4 cannot go into 3, you would then write your answer like this, right? 1 R3, 1 remainder 3. So when you're doing mods, you do this division like you normally would with long division, but the result is just whatever that remainder is going to be. So 7 mod 4, that's going to be 3. Let's do the other one. The other example here is 15 mod 2. We're trying to figure that out. So same sort of idea, do the long division first. So we're trying to see how many times does 2 go into 15. 2 goes into 15 7 times, right? 7 times 2, that's 14. So we have 1 left over. 2 does not go into 1. So that means the result of this long division is 7 remainder 1. Which means the mod, 15 mod 2, is going to be 1. Alright, so that's how the modulus operator works. If I ever say mod, that's just shorthand for modulus. That's what I mean. And again, in Python, we represent this with the percent sign. Alright, go ahead, take a couple minutes, again, pause this video, and figure out the results of these mods. These I want you to do on paper, so go ahead and try doing this long division example that I showed you with these 4 problems. Alright, so these are the results of those mod problems here. The one that I am going to point out is 85 mod 0. So again, to find the modulus, you have to do that long division, which means you would essentially be dividing by 0 to get that mod, right? So this second one was sort of a trick question. You can't divide by 0. So if you try to do 85 mod 0, you're going to get an error message. Alright, so for this class, whenever you're working with mods, don't worry about negative numbers in terms of negative numbers being the second number here in that mod equation. And also don't worry about numbers with fractions in them, right? Don't worry about floating point values. You only have to do mods with integer values or floating point values whose decimal point is 0. Alright, again, let me know if you have any questions about how modulus works. Alright, a couple more operators that I want to highlight and talk about specifically. I said division's a little bit weird in Python. Remember, there's 2 types of division. Let's talk about floor division first. So floor division is the one that has the 2 division signs. I sometimes call it double division, but it's really the floor division operator. The way it works, it does the division, and then it truncates the decimal. A better way to look at it, it does the division, and then it moves down to the left on the number line, to the next whole number. So for example, if you do 12 floor division 5, you're going to get 2, because if you divide 12 by 5, your result is 2.4, and again, the rule is with floor division, you just go to the left. Get rid of those decimal points. Go to the left on the number line. So you'll get 2. Another example, 7 floor division 4. If you do a normal division, 7 divided by 4, you get 1.75. And again, floor division, just go to the left. You get 1 as the result. So 7 floor division 4, you get 1. For negative numbers, again, just move to the left on the number line. Alright, so move away from 0 on the number line. So for example, if you have negative 7 floor division 4, again, if you do this division, negative 7 divided by 4, you get negative 1.75. Move to the left on the number line to get the floor division. So the result of negative 7 floor division 4 is going to be negative 2. Alright, so again, negative numbers, move away from 0, move to the left on the number line, always. Same thing with 7 floor division negative 4, that's also going to be negative 2. Do note though, the rules of division, if you have 2 negative numbers, your result is going to be a positive number. So in this case, you have the case of the previous example where you get 1.75 positive. So when you move to the left, you just get 1. Alright, so that's floor division. Again, the idea behind floor division, you do the division and then move to the left on the number line. Alright, we'll talk about the other division in a second, but first I want to mention this. So there are rules about mixing numerical types, right? We talked about how in this class we are going to talk about 2 numerical types in Python, integers and floating point values, right? Those are the 2 that we're talking about. So if you're doing any math calculations that involve, let's say, a mix of them, so maybe you're doing an integer plus a floating point number, or, floating point number plus another floating point number. There are rules about what the result will be based on the types that are involved with the math problem. So the general rule applies for almost all of these operators that I talked about. It applies for plus, minus, multiplication, exponentiation, floor division, and mod. Alright, so it applies for everything except single division. It applies for everything except the division we have not talked about yet. So it applies for everything except division with just one division symbol. And that rule is the result will be an integer only if both of the numbers involved are integers. Alright, so the second you have a single floating point number, and again, a floating point number is a number that has some decimal point value to it. So the second there's a floating point number, the result is going to be a floating point number. So if both of them are floating point numbers, you get a floating point number back. If one of them is a floating point number, you get a floating point number back. If they're both integers, you get an integer back. And again, this is for these operators listed here. Here's a couple of examples. Alright, so again, the rule is if they're both integers, you get an integer back. So this first example, if you do 5 plus 5, 5 and 5, both integers, so we get an integer 10 back. Next line, we have 5 plus 5.0. We also have 5.0 plus 5. In this case, one of the numbers is a floating point value, right? That 5.0 is a floating point value because it has a decimal point. So the result of both of those is going to be a floating point value, 10.0. Next line, these are both floating point values, 5.0 plus 5.0, so we get a floating point value back, 10.0. And again, these rules apply for almost all the operators. They also apply for, say, exponentiation, right? 5 to the power of 2, these are both integers, so you get an integer 25 back, and so on. Alright, so the general rule again, if both of them are integers, you'll get an integer back. If one of them, or both of them, are floating point values, you'll get a floating point value back. Here's the exception, right? I said that rule applies for almost every single math operator. This is the exception, is this division. Alright, so single division symbol. So this is not floor division, this is a single division symbol, just one of these. Always results in a floating point value. Always. So even if both of the numbers are integers, for example, 5 divided by 1 with the single division sign, you are always going to get a floating point value back. It's just kind of a weird thing about Python. Again, keep in mind, floor division, the one with the 2 division signs, double division, that works like the other operators, alright? So that follows the sort of standard rules about mixing types. Just to illustrate that a little bit further with a couple of examples. So again, with single division, this is just normal non-floor division. You always get a floating point value back. So 5 divided by 5, even though they're both integers, you get the floating point value 1.0 back. Alright, any of these examples in the second line, since they're all just the standard single division, you're always going to get a floating point value back. Once it's floor division though, right, this is going to follow the normal, quote-unquote, normal rules as before. If they are both integers, like 5 and 5, you will get an integer back. On this last line here, the second one of them is a floating point value, like 5.0, you'll get a floating point value back. So I know division's a little bit weird with Python. This is one of those things that you kind of just have to memorize. So do keep that in mind. If you have questions though, please let me know. Another thing to keep in mind is PEMDAS, or whatever order of operations mnemonic you might have learned. So PEMDAS does apply in Python, meaning you treat parentheses first, then you do exponents, then multiplication, division, and modulo. Those all have the same order of precedence, so for those three, just go left to right in order. And then the last order of precedence is addition and subtraction. And again, those are the same level. Addition and subtraction are on the same level, so for those, just go left to right. So this is going back to, you know, those fun PEMDAS days in elementary school. So this, again, this is talking about order of operations. You can use parentheses in Python to force those order of operations if you need to. Otherwise, it'll follow these standard rules. Alright, keeping that in mind, I recommend, again, pausing the video at this point, running through these two examples on paper. So again, the rule is try to figure out on paper, use those variable box drawing diagrams to help you sort of keep track of what's going on. And once you get your results, come on back to the video and double check and see what you got. Alright, so hopefully this is what you got. I will go ahead and work through code A. I'm not going to do both because it's kind of similar. That said though, if you do have questions about code B, please let me know. Another thing you can do is if you got stuck at some point, is to run this code, type it up, run your code, and you can double check what happens at each line by printing out the result of the variable. So you can add extra print statements just to see, you know, what's going on here. Alright, so again, I'll go through code A. If you have questions about code B or either of them, please do let me know. So let's go ahead, walk through code A. Alright, so by now you know that I like to do these variable box drawing diagrams. I do think they are helpful, so please do them. Alright, so we start off with three variables, x, y, and z. So let's go ahead and draw those boxes. Alright, and these values, x starts as 4.0, and that is a floating point value, right? Because it has that 0.0. It's important for problems like this to keep track of those types. Not just that they're numbers, but whether they are floating point values or integer values. Alright, so x gets the value 4.0, y gets -10, that is an integer, and then z gets 1.5. Alright, so that's these first three lines here, these first three assignment statements. Let's talk about this line right here. Y equals y plus 12. Alright, so again, same rules before. Do everything on the right-hand side first. At this point in time, y has -10 in it. So we do this, and then our result is 2, right? -10 plus 12, that gives us a 2. Again, this is an integer, right? So pay attention to your types as you're going through this code line at a time. So we put this 2 into this y here. So we'll go ahead and update this. Y is now 2. Awesome. All right, next line right here. X equals x asterisk asterisk y. Try saying that 5 times fast. All right, so we have this x equals x y. All right, so again, these double asterisks, those mean power, or doing an exponent. Do the right-hand side first. At this point in time, x is 4.0. Make sure you have this 4.0. That does make a difference because it is a floating point value. And then we have 4.0 raised to the y, which at this point in time is 2, right? Use the most recent value. Alright, so this will give us 8.0. Alright, so be careful about that. 4 to the power of 2 is 8, but since one of them is a floating point value, the rule is the result is going to be a floating point value. Alright, so at this point in time, we've done this right-hand side. We can put this 8.0 into x. So let's go ahead and do that. Alright. Got a couple more lines to work on. Alright, so let's look at this next line here. This next line is a little bit more complicated. There's a little bit more going on. So this line right here is what I'm talking about, this z equals line. So we start with this. Z equals parentheses z plus x mod y floor division 1. Alright, so there's a lot of stuff going on in here, right? First, let's just rewrite it so that we have all the values that we're working with. So right now, z has 1.5 in it, x has 8.0 in it, y has 2 in it. So we look like this, right? Alright, so the rule is, remember, follow PEMDAS. So we first do everything in parentheses. Inside these parentheses, following again the rules of PEMDAS, we're going to do this modulus before we do this addition. So let's look at this 8.0 mod 2. Okay, so again, the rules with mod is you do the long division. Alright, so this is the long division. How many times does 2 go into 8.0? Well, 2 goes into 8 4 times. 2 times 4 is 8, nothing left over. So this mod is 0, but be careful about that because the result of that is going to be a floating point value. Alright, so mod follows the normal rules. Since one of these is a floating point, that answer is going to be 0.0 right there. Alright, let's continue with the rest of the math here. So again, let's finish off these parentheses first. So here we get 1.5, right? 1.5 plus 0.0. We're going to get a floating point back. And then we finally do this floor division. Alright, so again, the rule of floor division is you do the division. So 1.5 divided by 1, well, that's 1.5, right? But then you floor it. So you go to the left on the number line. So if we're at 1.5 on the number line, and we move to the left, the next number is going to be 1, right? So the final result of this whole right-hand side right here, the value that we're going to put into z is, I almost forgot, it's 1.0, right? So it's not just 1, it's 1.0 because with floor division, it follows the standard rules. Since one of these numbers here is a floating point value, the result of it is also going to be a floating point value, which is kind of weird with floor division, right? Because the whole idea of floor division is we're rounding down to the left, but that's how it works in Python. So since one of these is a floating point value, the whole result of this is going to be a floating point value. So z gets updated to 1.0. Alright, that's this line of code. We got one more to go, right? We have this one, and then we finally do our print. So let's do this one last line of code. Alright. Last line of code, x equals 4 plus y times 2. Awesome. Let's do that. X equals 4 plus y times 2. Alright, cool. Right hand side first. Just rewriting it with the values. So y right now is 2. Alright, and then again, the rule with PEMDAS, we're going to do this multiplication first. So we get 4 plus 2 times 2, which is 4. We do this addition. 4 plus 4 is 8. And it is an integer this time because both of these numbers here are both integers, right? So again, with addition, if they're both integers, you get an integer back. Alright, so that means at this point in time, we now update x to be 8. Finally, we do this print statement, right? We print x, y, and z. They're separated by commas, so when they're displayed, they will be separated by spaces. So x at this point in time is 8, y at this point in time is 2, and z is 1.0. Alright, again, if you have questions about code B, please do let me know. That said, if at any point, let's say for example, you're not so sure about how this line works, you can go ahead and type up this code and then add an extra line right here that prints B, for example. Or maybe you're not sure how this line of code works. Add an extra line right here, print C. You can add these extra print statements to sort of show you what the values of these variables are after each assignment statement. That will help sort of explain what's going on in each step. Alright, if you have any questions about this, please do let me know. Otherwise, I'll see you at the next video.